Okay, folks, back here on DM Radio. What an interesting show so far. We talked to Citizens Bank, we talked to That Dot, and now we've got Sanjeev Mohan of Sanjmo, who is one of the best analysts I've come across in my days. And he's been around for a while watching the market, and he's got a very interesting take on streaming versus batch. Of course, batch oriented, persistent data, that's the old way of doing things. And Sanjeev, you just said something really compelling as we were chatting before this segment recording began, and I'd love for you to say it. So tell me about streaming versus batch.
So what I was saying, Eric, was that streaming is real life, batch is not. Batch is actually a casualty of how the original computer systems were designed and built. They were like super expensive. So processing data in real time was a luxury. No one wanted to spend that much money on it. Uh, and that's why we went to batch, because you could do nightly data processing. But the problem with batch is that it's all after the fact, which means that, let's say, somebody has stolen a credit card and is abusing it. You want to catch that fraud in real time, not at night when you do your reconciliation.
That's
And
right.
so this is why, but we couldn't do it. In fact, I would say that because streaming is mainstream, batch is actually a subset. It becomes a use case of my streaming data. Streaming data is
Mhm.
unbounded. It's always coming. But if you say that, you know what, I'm going to put a start and an end date into that stream and process it, then that becomes batch. So batch becomes a special use of streaming data instead of thinking it the other way around. So we
Right.
shouldn't be thinking of streaming as a standalone, something brand new, different from the way we've done data processing. It should become the standard, and batch should be a use case of that.
Well, right. I mean, back in the day, we had straight through processing, right? Isn't that what they called
Yes,
it? Is
correct.
straight through processing where you were doing real-time processing.
Right.
And to your point, batch resulted from a recognition of costs and hardware
Yes,
limitations, and we just couldn't
correct.
do it all. So we settled for little snapshots of the world. I mean, it's not as bad as just a photograph, but
Right.
it is in a way a difference between a little snippet and the whole picture. And as you suggest, the stream is the whole picture. Here's what's happening right now in totality. My big
Uh,
question has always been around the historical side. So you're getting data streaming at you. You have to persist something somewhere to know what
yes.
happened before.
Mhm.
So how do those architectures typically work? What have you
Yeah.
seen?
Yeah. So this is why Kafka became so popular, because before Kafka, it was all about messaging. So message
Mhm.
passing, straight through processing.
MQ
And
series, right?
MQ series, exactly. When Kafka came out, Kafka said, "Oh, wait, we are log-based streaming, but we have got log persistence, and that means I can replay it." And that's very important, because in streaming, it introduces new challenges that we never had to deal with in batch. Because batch is clean cut, it's dry, and it's right there with begin and end. But what happens is, let's say I'm doing some processing. I'm driving a Tesla. It's a self-driving electric car. So I've got all these signals that somebody is processing. I go through a tunnel. All of a sudden, signal is gone. I come out. So now that data is late arriving data, or it's out of
Right.
order. These are
Right.
the problems which are very hairy to deal with. And so persistence is needed, processing is needed and this is why we've got different flavors. Am I going to process the data once and for all? And if it doesn't show up, forget about it. Or I'm going to do exactly once. I want to ensure every data was processed only once. So these are the challenges that uh, things like Kafka and other things built on top of Kafka solve for us.
Yeah. I mean, there are still challenges in aligning your topics and
Mhm.
understanding the metadata and figuring out the use
Yeah,
case. But I mean, I'll tell you the
correct.
thing that I love the most, As soon as I heard about Kafka and wrapped my head around it, which is about 10 years ago, I
Hmm.
realized this is very interesting because typically when you do all these batch processes for different departments, you wind up with all these silos. And with streaming, if you do it right, you can have one stream of, let's say, customer transaction data, and the marketing people can subscribe to that stream if they want.
Yeah,
The accounting people obviously want to subscribe to that. So anyone can subscribe to it and get it. And now you're all part of the party. You're all getting the same information at the same time. Now you may do things differently with it. You may put different filters on it to pull out what's meaningful for you, for example. But nonetheless, you kind of solve that point to point integration problem, which is a mess. I mean, when you get past 14 batch windows, all of a sudden it's like, all right, now which data is going where and for what purpose? It kind of goes off the rails and
right.
stays off the rails in a lot of these environments, right?
So actually, the point you raised is extremely important. And there's what you said is really profound. What has happened in our space is that all our attention has shifted to analytical architectures, to the right side of the equation. We talk about lake houses, ETL, ELT, change data capture. So we are taking all the streaming data and what you just said exactly, all these pipelines, and we are munging it together, and we are preparing it for consumption by downstream. But if we shift our attention to the left-hand side, the operational side, and we say, let's shift left and let's handle the stream of data as it comes in. And of course, it may need to be joined and enriched and all of that. Then we can actually ensure that downstream systems are all consuming data from the same source. In MQ series and some of the previous ones, once the message was consumed, it was deleted. But in
Right,
Kafka, that message is going to stay because it's
right.
persisted in logs. And so you can, retry. So basically, by moving the downstream systems to consume data as it originates, you can shave off all this confusion with the middleware piece.
Wow. Yeah, that's such a good point because that winds up taking tremendous amounts of time and effort. And it's
Yeah.
also just very difficult and unwieldy to deal with. Now, there are other issues to handle. I mean, when
Mhm.
this kind of reminds me of doing some sort of massive government re-regulation, where
Yeah.
if you just change one thing, you're
Yeah.
never going to get there and it's going to cause lots of
Yeah.
trouble. So you have to change everything, but changing everything at once is extremely difficult. I mean, it's almost impossible. The guys from Citizens Bank were telling me it's taken them a while, but now they're like 80, 85% in the cloud, and they expect to be
Hmm.
95% in the cloud next year. And it's all driven on a streaming architecture. So if you think through all
Amazing.
the use cases,
Yeah.
fraud obviously is top of mind, but even customer data, they mentioned right now, if you go and change your name and address in some
Yeah.
system, it takes days for that data to persist to all the different operational systems that need customer data. If you subscribe instead to a stream of customer data and you've got those log files for your persistence, that problem is solved. And they said now, when someone updates their data, it's updated in seconds across
Yeah.
the entire organization. It's like, hooray. Talk about
Yeah.
customer experience. What do you think?
Yeah. In fact, if we expand the use cases to the topic du jour, which is AI, then it even makes it more interesting because let's say I in my streaming architecture like Citizens Bank or something like that, they're let's say pointing their system to a bucket in an
Hmm.
object store in the cloud provider of their choice, and a new file comes in. I want to accept that file right away, and I want to take that. So as soon new piece of data comes in, I want to read it, chunk it, embed it, and make it available to do my RAG pipeline, my vector search, or
Wow.
or in the near future, do continuous fine tuning of models. See, right now, what
Ooh.
happens to a model? We train the model uh, once in years, and then we say, oh, this model does amazing job, but it's out of date. So if we get to a point, which we will very soon, where we can continuously fine tune it, then it's going to piggyback on the streaming architecture, because it's going to, as soon as new piece of data comes in,
Wow.
we're going to fine tune the model.
Yeah, that is very interesting, folks. And we've got a podcast bonus segment coming up here with Sanjeev Mohan of Sanjmo. We're going to dive into that because I'm still trying to wrap my head around exactly what that means and exactly how that works. But it is
Mhm.
a big deal. You either RAG, retrieval augmented generation, you work on your RAG model, or you fine tune. You could do both, obviously. But the question is when, how, why do you do those things? What are those strategic decisions? We'll be right back. You're listening to DM Radio. All right, folks, back here on a fantastic DM radio. First half was recorded in Austin at the Confluent Current event, and now the second half is with my buddy Sanjeev Mohan of Sanjmo. And at the end of the last segment, Sanjeev, you mentioned this whole concept about streaming and using that to fine tune models. So you take these models, they have billions sometimes of parameters. You don't have to have that many. You can have millions of parameters. It's really up to you. And there are different architectures to models too, many different layers, and you have inference layers, you have ingest layers, all these things are going on, and they're all different, they're all bespoke. But what's interesting is, of course, first of all, they're probabilistic. So how do you deal with that? How do you deal with the fact that they're not always going to be correct because they're converting text or imagery to numbers and then back to text or imagery? That's a bit of a lossy process. You're going to lose a little bit of accuracy on there. It's not like the old database world where you get a specific record that you want. Not that it always worked, but
Yeah.
this is a little bit different. So there is that issue. So you can either use RAG models, which where you have your vector database, you populate it with all the embeddings of your corporate data to kind of weight the model towards your reality, towards the answers you want it to give, or you can fine tune the model. And I'm trying to understand exactly how that works. So from your perspective, what's the difference between fine tuning and a RAG model?
Okay, so I can answer that. So Eric, if we just talked a few minutes ago how models are tuned at some point in time or trained at some point in time, and then we, because it's too expensive to constantly train
Right,
400 billion parameter model, so you do it once, and then so a few things happen when we do our chat GPT, like we ask questions. So there are two problems, actually two or three problems. The first problem is the data is out of date. Second problem
right,
is it does not know anything about my own data. And the third problem is that there's some memory, how much data you can pass to it, which is a context window, which is also limited. So now with these three problems, we get into the next stage after prompt engineering, which is retrieval augmented generation, RAG. In RAG, what we say is that instead of asking the model the question for which it doesn't really have an answer, I'm going to first do a search on my own database to build out a sort of a body of knowledge that I
right,
can then pass to the LLM. So,
right.
so, so the first part is retrieval. So I've done a search, then retrieval augmented generation. So I'm going to say, Mr. LLM or Ms. LLM.
Right.
Here, got to be politically correct, here is my data. Now I want you to summarize it. I want you to tell me which what's the sentiment of this data I just sent you. So see how powerful this is. So it's a combination of retrieving my own data, sending and then compressing it because the context windows are limited, and then asking LLM to do what it's really good at doing, which
Right,
is similarity search, predicting what is
right.
the next word that comes in. So this is the combination of why RAG is important. Fine tuning basically says that what if I keep, like, I have a base model, it's open source like Llama 3 or Mistral or something like that, where I can then pass some of my own data and train some additional layers on top of the base, because
Oh,
the base model already knows all the grammar. It's already been
right,
trained. It knows
right.
the basics, but it doesn't know my own corporate information. So if I can piggyback that on, then I can just use the model out of the box. I don't necessarily have to do RAG, but we are not there yet.
Right. So
In the
it is typically a layer. That this is kind of what I was getting at,
yes,
right? Because you have
it's
many, many, many
correct.
layers in these
Yes,
models, and there are all
yes,
kinds of ways you can do it. You can have all sorts
yes,
of inference layers, analytical layers, all these different things that come out and generate an output. And
yes,
so with fine tuning, you're creating additional layers either at the beginning or at the end of the process or
yes,
somewhere in the middle of the
correct.
process, for
Yeah,
example,
yeah,
to check and to double check.
yeah.
And I think that's this is a very good explanation because let's face it, I'm preparing a talk right now,
Hmm.
probable cause, a Gen AI warning, which says, hey, which part of your business can be wrong 5 to 10% of the time?
Yeah,
Sales, accounting, can accounting be wrong 10% of the time?
right.
No, like it
Yeah,
cannot be. So this
right.
concept of hybrid search is coming through and
Yes.
fine tuning, and you really want that last mile to be very accurate depending upon the use case, right?
Yes. So you want to reduce hallucination for sure. But there's also a very critical point. Let's say I want to run, I want to find out who are the top salespeople in my region.
Hmm.
And that is not a good query for an LLM because there's only one right answer based on the volume of sales done. This is a
Right,
deterministic query. I should write a SQL statement for that. But
right,
if I want to do more of like creative stuff, why did this person sell so many widgets in this territory of this color, of this size and this price? Like that kind of like, esoteric
right.
stuff. Uh, you
Which
know,
would befuddle a SQL
y-
query,
yes,
right? Like
correct.
it would just
And
crash and burn.
right. And if we understand, in fact, I heard this a long time ago that we humans, we are always hallucinating. Whether we've taken anything special or not, we're always hallucinating. If we
Mushrooms, yeah.
like it, then we are like, oh, this is a great answer. If you don't like it, then we call it hallucination. So
Interesting.
so it's a probabilistic model. It's going to come up with what it thinks is the best answer. If that answer is up to my liking, then I'm like, wow, this LLM rocks. If it is not, I'm like, oh my God, how dare you? Yeah. So
That's funny. And I've noticed, you probably noticed this as well. And folks, email me info@dmradio.biz if you want to be on the show. But I've noticed that Google itself is now shifting between more deterministic and more Gen
yeah,
AI use cases. When you do a query,
yeah,
sometimes it'll give you the old answers and sometimes it'll give you a new Gen AI answer. So it's got a bit of a sniffer on the
yeah,
front end there to go, okay, should I go deterministic on this one? Should I go
right,
Gen AI? And it kind of
yeah,
makes its mind up. And that's what we're talking about is
right,
what you're going to see in the enterprise is a mix and match of these things because
yeah,
I think the power of these foundational models has just begun to be tapped. We're just now
yeah,
learning about what they can do, and I think there's tremendous potential here. But leave it to Sanjeev Mohan to articulate things so clearly,
yeah.
folks. And
I
final
want,
thoughts from you, 30
yes. So
seconds.
final thought. See, today, if an LLM tells me to put glue on my pizza or how to eat rocks, I can laugh and I can ignore. I can say, oh,
Right.
here goes LLM. But we are moving into a very exciting, a bit dangerous territory of agents. These agents are
Oh,
autonomous. So one
right.
agent is going to call another agent. They're going to do multi-step reasoning. They're going to execute a very
That's right.
complex workflow. If it
That's right.
hallucinates, imagine
Right.
that. There's no human
Yeah.
involved, it's autonomous.
Yeah.
So that's why we need to first fix the accuracy problem before we can let loose these agents.
That's a very, very good. This is exactly my thought too, because once and my whole question is, how are you going to manage and shepherd the behavior of these
Mm,
agents? Is it going to be log files? Is it going to be a hard limit on the number of transactions they can do before you check in with them? I mean, this is
mm.
not a simple problem to solve
It's
because,
not.
again, they are multivariate. And if you've got a bunch of them
Correct.
talking to each other, like, wait, hold on, man. That's like
Yeah.
unleashing an army of robots across the country, and you don't know
Yeah.
what they're going to do. So
Yeah.
it's
Good
very
point.
interesting. We'll tackle that on a future show. Thanks so
Sounds
much for
good.
your time today, folks. You've been
My
listening to
pleasure.
DM Radio.